we go. Share the screen. Okay, so we're up to 12.2. So we are over here. We're doing integration still by substitution. Okay, so that's the main focus for today. So we do one section a day. We only have 3 weeks left. Okay, so schedule-wise, let's look at this. So December the 1st, here we are. So 12.2. If I can sneak in just the introduction at 12.3, I'll do that. Okay, then Thursday, I'll do 12.3 and sneak in 13.2. That's just so I can finish a little faster. Thursday will be our last regular quiz. It'll be on integration. Okay, so 13.2, I'll try to finish it up and then let you ask questions. Last regular test is on the 10th. Okay, the 15th is a question and answer session. And the best way to study for the final exam, again, is to go back and review all the previous exams. For the final exam, you can use all the previous cheat sheets, all the formula sheets. Don't bother making new ones unless you threw it away or if you can't find it, then I guess you have to make it all. But if you still have the formula sheets for the first test and the second test, right, and the third test and the fourth test, just keep it, and you're developing the fifth one, and just keep them all and use them all for the final exam, okay? So that's what's going to happen. All right, so I'll do 12.2, maybe just sneak in some of 12.3, and then let you ask questions when I'm done with that, okay? And again, you already know the way it works, that my questions don't necessarily match your questions, but you know, you're still learning the material, hopefully. All right, so let me get started with 12.2. Okay, so 12.2, we're doing integration by substitution. This is kind of the chain rule in reverse. Okay, chain rule in reverse. Okay, so integration, like this symbol, like we did last time, right? We're trying to find antiderivatives now. Okay, so integration by substitution. Here are the things that you want to look for. Okay, and yes, at the beginning it won't make any sense. Okay, so just take note of this. It won't make sense, but maybe by the time you look at the third and the fourth and the fifth one, maybe some of this starts to sink in. So you look for a function and its derivative, or a constant times the derivative, whatever that means. Okay. Excuse me. Look for a function and its derivative, or a constant times the derivative. We're going to let u be the function. Okay. This is something called u substitution. That du is the derivative of the function. Okay. I do hear somebody in the background, so can everybody mute themselves again, please? Okay. Everybody please mute. So u is the function, so-called u substitution. Du is the derivative of the function. So we're looking for a function and its derivative, or maybe a constant times the derivative. So you don't have to quite see the derivative, but a constant times the derivative. If you're off by a constant, that's going to be okay, as I'll show you. All right, now you've seen this du dx notation before, right? It's sometimes called the Leibniz notation. I'm not really testing you on that, but Leibniz notation. It's the d stuff. So the du dx is the Leibniz notation. Okay. We're actually going to end up multiplying both sides by dx. Okay, so the left-hand side is always going to say du. The right side is going to be the derivative times dx. Okay. Yeah, I understand right now you're probably saying, I have absolutely no idea what you're talking about. Okay, and that's all right. Okay, just get the rules down, and then I'll refer back to them. And maybe by the time we look at the third one or the fourth one or fifth one, maybe some of this sinks in. Okay, so the concept is look for a function and its derivative. The first examples would be the actual function and its derivative, or maybe a constant times the derivative. Okay, we're going to let u be that function. We'll do a u substitution. Du is the derivative of the function times dx, and then we'll go from there. All right, so here we go. Problem number 8. I'll get started. And again, you should know this is my 8. I don't know if it is your 8 or not, but you get the, or it might be off by a little bit. Okay, so the function is 3x cubed plus 1 to the fourth power times 9x squared dx. Okay, offhand, does anybody know, is that actually the one in your book? Or is it off by a little bit? Can anybody let me know that?
Professor, can I ask a quick question? Sorry for interrupting.
Huh?
Can I ask a quick question? Sorry for interrupting.
Yeah, go ahead.
What does it say in black ink?
Right here? Yeah,
Yes.
Leibniz notation, Leibniz. Leibniz notation. I'm not testing you on it, but this D stuff, the du dx, Leibniz, Leibniz, Leibniz notation.
Thank you. Sorry.
All right. Can anybody tell me if this is the actual problem? Does it match what you guys have, or?
It is.
Yes.
Does it match? Okay. All right. Okay, so here we go. What's the derivative of 3x cubed plus 1? 9x squared. Okay. So this falls into the category of look for a function and its derivative. Here's a function, 3x cubed plus 1. Don't include the 4. Ignore the 4. The derivative is 9x squared. So let u be the function. So u, I have it circled here, u is 3x cubed plus 1. So let u equal 3x cubed plus 1. Du is 9x squared dx. So we're going to write it like this in general. And this is the Leibniz notation. Just have cut the end there. Leibniz notation. Okay. Now you've seen this before. U equals 3x cubed plus 1. Du dx is 9x squared, right? That's one of the notations for derivative. Du dx is 9x squared. Pretend you multiply both sides by dx, and then it looks like this. And this is the way we're normally going to write it. If I multiply this side by dx, you just have a du, and this becomes 9x squared dx. But in general, for this section, we're going to go straight from here to here. Okay, so one more time. Look for a function and its derivative. Okay. Here's the function, 3x cubed plus 1. Don't include the 4, just 3x cubed plus 1, whose derivative is 9x squared. So let that be u. U equals that function. And here's my du. Okay, so u is 3x cubed plus 1. So the next step, okay, I write I for the original integral. Otherwise, I'd have to rewrite the beginning all over again. You don't feel like writing that whole thing. I don't feel like writing that whole thing. So my notation is capital I will mean the original integral, rather than rewriting that all over again. Okay. So instead of 3x cubed plus 1 to the fourth power, it's now u to the fourth power. Much nicer. Okay. So I replace 3x cubed plus 1 with u. I replace 9x squared dx, see 9x squared dx, with du. So I'm now integrating u to the fourth du, which is very easy. So the harder integral became easier. If I change that to u, instead of this mess to the fourth, it's simply u to the fourth. And then all of this stuff becomes du. So now I just integrate u to the fourth. That's easy. U to the fifth over 5 plus c. And then just change u back to what it was. Okay. And I usually like to write my answer like this. Dividing by 5 is the same as multiplying by 1/5 from arithmetic. If you divide by 5, you multiply by 1/5. Okay. And then just change u back. What was u? 3x cubed plus 1. So there it is, 3x cubed plus 1 to the fifth power plus c. So this is my final answer. 1/5, 3x cubed plus 1 to the fifth power plus c. So this was a u substitution. And if you try to differentiate this, you should get that back. Okay? See if you can follow the logic with me. What's the derivative of this? Okay, the derivative of any constant is 0. You know that, so don't worry about that. Okay, if you take the derivative of this, 5 hits the 1/5. What's 5 times 1/5? 1. 3x cubed plus 1 to the fourth power. There it is. And then by the chain rule, it's times the derivative of the inside. The derivative of the inside is 9x squared. So there it is. It works. Okay, so that's also what I mean by it's sort of like the chain rule in reverse. Okay, so you can double check by doing the chain rule on the final answer. So the derivative of this is indeed this. So it looks like we did it correctly. Okay, I'll do more, many more.
Professor Holm,
Yes.
the homework start with number 5.
The homework starts at number 5. Uh-huh. Okay.
So we start on the 5 or we start on the 7?
Does it look like it starts with 7 on yours?
No, it's the same number.
Same numbering?
Yeah.
Okay. Then yeah, start with 5 then.
Because your number 8 is the same as our number 8.
Yeah, that's okay.
So we will start from number 5.
Start from 5, yeah, as usual.
Okay.
Okay.
Thank you.
I'm choosing not to do all the evens if you were thinking about that.
No, there is number 6. You didn't do the number 6. You go number 8. That's my question. So I just wondered.
I was never obligated to do all the evens.
I know, but I'm just curious. So, okay, that's all right. Thank you.
Okay, number 10. All right, so the original says 8x to the 4th plus 5 cubed, 32x cubed dx. Okay,
I have a question before you go forward, sir.
Function and its derivative. 8x to the 4th plus 5 has a derivative of 32x cubed. Okay, so once again, it fits the pattern of look for a function and its derivative. Let u be that function. So let u be 8x to the 4th plus 5, whose derivative is 32x cubed dx. Okay, so again, this is the way we're normally going to write it. We're not going to write du dx equals 32x cubed. Okay, multiply both sides by dx, so to speak. So we'll go straight to this from now on. Okay, so one more time, here's a function whose derivative is elsewhere in the same problem. The derivative of 8x to the 4th plus 5 is 32x cubed. Don't count the 3. Having the exponent of 3 doesn't bother me. Okay. All right, so this now changes to u cubed. Much nicer than 8x to the 4th plus 5 cubed, u cubed. Okay. All of this is du. So I changed from a much harder looking problem into just u cubed du. Very nice. Okay, so integral of u cubed, u to the 4th over 4 plus a constant. Change u back. Now, if you want to leave the answer as divided by 4, that's okay. You must change u back though. You can't leave your answer as u. I mean, if you stop and think about it, the original problem is all x, right? So it'd be kind of weird if you start off with x to leave your final answer as u. That wouldn't make any sense. So just change u back to what it was. So I changed this to 1/4. Again, dividing by 4 is the same as multiplying by 1/4. U to the 4th is now 8x to the 4th plus 5 to the 4th power plus c. And so there we go. Okay. Let me check by taking the derivative. What's 4 times 1/4? 1. 8x to the 4th plus 5 cubed. There it is. And then by the chain rule, times the derivative of the inside, which is 32x cubed. Perfect. So the derivative of this is indeed this. So we know we did it correctly.
Professor?
Yes, question.
Why are we even given du? What's the purpose of that? To confuse us?
I'm not sure what you mean by why are we, you're not given du.
I mean 32x to the 3rd dx. We never use it later on. Why are we even given it?
Well, it makes this problem easier. I mean, that tells me I have the right antiderivative.
Mm-hmm.
To integrate this one is actually much harder. The only way you can do that is to multiply it all out, and you don't really want to do that. I don't want to do that. Okay, but by means of this substitution, it becomes fairly straightforward.
Mm-hmm.
Okay. the derivative of this did come out to be this, so it worked.
Okay.
In other words.
So Professor Holm, after we change it to u third du equal to u fourth and fourth plus c, you change it back to 1/4 with parentheses of u on the top 8x4 plus 5 to the power of 4. So you change it to u and then you change it back again.
That's
Is
correct.
that what you're looking for?
That's the technique, yeah. The whole idea is to temporarily change it to a much easier integral. You look at the original integral and look at what I changed it to.
So you
And yes, the final
basically
answer
just,
has to involve x. So u
Yeah,
is just
so-
a temporary variable.
so you basically ignore the du, which is converted to c only.
The du, yeah, I mean, we were always doing that, but it does name what the variable is. If it's a u, you're supposed to have a du. If it's an x, you're supposed to have a dx. But other than that, you're right, it doesn't serve any function. Okay. But it was necessary. You can see that everything kind of clicks, so to speak. I started off with dx. I temporarily switched to du, and then we're back over here again. Okay.
So basically 8x to the fourth power plus 5, the derivative of that is equal to 32x squared.
The derivative is 32x cubed.
Right.
Yes.
And then the dx is really the third power up top.
32x cubed dx, this whole thing is equivalent to du. Okay. And then I make my substitution here.
But the dx is basically the constant.
dx is not a constant. It pretty much names the variable. It just tells you that I'm doing x here, and it tells me I'm doing u over here. It is a relationship between x and u. This tells me a little bit how the u and the x change themselves. Okay, if you're bothered by that, just think of it as a notational thing right now. I could really go through a rabbit hole and tell you more of the reason, why it's there, but I don't want to go that and I don't have to. So I think I'd rather not.
Yes, and then the next step, basically the u to the third power, the u is really the 8x4 plus 5
Correct.
to the third power.
Correct.
Right, and then the du is the 32x cubed dx.
Yes. That whole thing, right. Just erase that whole thing, put it like that.
And then the u is really the n plus 1, which is u3 plus 1, u4
Yes.
over 4,
That's right.
plus the constant.
Correct.
Okay, so at this step, can you show how to go from this step to the quarter, to the 1/4 over?
Yeah, all I did was change dividing by 4 to multiplying by 1/4. That's from arithmetic, right? If you divide by 7, you multiply by 1/7. Okay, or you could also, you can sneak in a 1 here, right?
Okay, so here is when you replace the u for the actual 8x4 plus 5
Correct. U is now replaced by this.
to the fourth power.
To the fourth power, yes.
Okay.
So U was that, says it right there. There's dividing by 4 right here. Divide by 4 and then plus C.
Can you do that the step above? Instead of putting u to the fourth, can you just do 8x to the fourth plus 5 to the fourth?
You can, but I don't want you to.
Over 4, okay.
Yeah, I know what you're saying, but at this stage, I want to see every step.
Okay.
Okay.
Thank you for clarifying. Thank you.
Right, welcome. Okay, number 12. Still follows along the same thread. So 4x squared minus 3x to the fourth, 8x minus 3. Okay, so I see a function and its derivative. Okay, what is the derivative of 4x squared minus 3x? It is 8x minus 3, and there it is. So same theme. Let u be 4x squared minus 3x. du is 8x minus 3 times dx. So instead of writing this mess to the fourth power, it's just u to the fourth power. And instead of writing 8x minus 3 dx, I get to replace it with something equivalent, du. Right, so similar theme. And now that's easy. U to the 5th over 5 plus c. Change u back to what it was. Dividing by 5 is multiplying by 1/5. And what was u? 4x squared minus 3x. So 4x squared minus 3x raised to the 5th power plus c. So that's the way that one goes.
Sir, and then that would be the final answer. You don't have to figure that out.
This is the, yeah, just leave it here. If you talk about
Is-
raising it to the 5th power, no way anybody feels like doing that.
Is there a step past this step here?
Okay, you talking about this one here?
Yes.
No, this is the final answer.
Okay.
That's been the nature of all the previous ones too. Once we get to the substitution back, then you're basically finished. So just leave it like that. And something for you to try is check to see if this works, which means take the derivative of this, hopefully you get that thing back.
Professor,
Yes, question.
I think most of the homework questions, they ask us to do the check, right? Do we have to do all the steps?
Yeah, I mean, it's always a good idea to check. I mean, that's been true since day one. It's never wrong to double check your answer if possible. And I've been doing it for a couple of these. So check by taking the derivative, see if you get that back. All right, now the problems get a little bit harder. So up to now, I've been doing this. Look for a function and its derivative. Now I'm going to do the or part. Or a constant times the derivative. What does that mean? You might have the derivative not quite there, but if you multiply by constant, you're still okay. Okay, you say, what do you mean by that? Okay, so here's number 14. Temporarily ignore the red and the green. Here was the original problem. 9x to the 5th, 3x to the 6 minus 4 to the 6th power dx. Yeah, let me just take a quick peek in my book. Yeah, so it's a little bit different there, but all right, 9x to the 5th, 3x to the 6 minus 4 raised to the 6th power dx. Now, one thing you should be comfortable with is the derivative of something with x to the 6th is going to be x to the 5th, right? So that sort of tells you which way to go, right? The derivative of x to the 5th is going to be an x to the 4th, which I don't have. But the derivative of x to the 6th is going to have an x to the 5th. So the most likely way to go, right, is to say, let this thing be my u. Okay, so rather than having something complicated like 3x to the 6 minus 4 raised to the 6th power, how about just u to the 6th power? Okay, so let u be 3x to the 6 minus 4. U equals 3x to the 6 minus 4. Whose derivative, so what's the derivative of this? So don't look inside here. Just go ahead, pretend this is not even there now. Just look at this. What's the derivative of this? 18x to the 5th dx, right? 18x to the 5th dx. I don't have 18x to the 5th dx. I do have 9x to the 5th dx. Okay? And the claim is that's going to be all right. Okay? That fits the bill of a constant times the derivative. So I'm saying to myself, okay, in order for me to substitute, I need 18x to the 5th dx. What do I have? 9x to the 5th dx. Okay? If I multiply by a constant, namely 2, that's going to be all right. So I need 18x to the 5th dx. I mean, the derivative of 3x to the 6 minus 4 is 18x to the 5th dx. I only have 9x to the 5th dx. They'll match if I multiply by 2, because 9 times 2 is 18. So the way you do that is multiply 2 inside and multiply by 1/2 outside, because 2 times 1/2 is 1. So I'm not changing the value of the expression. Okay, so in red, I multiply by 1 in the form of 1/2 times 2. So I leave the half outside. Now I'm ready to substitute. So what's all this red and green stuff? Okay, so 3x to the 6 minus 4 is my u. So the next step, instead of writing blah, blah, blah to the 6th power, is going to be u to the 6th power. And then in green, all of this stuff. And by the way, you might say, well, they're not together. It doesn't matter that they're together. Multiplication is commutative. That means you can change the order anytime you want. So I can pick this up and move it over there. So I do have indeed 2 times 9, which is 18, x to the 5th dx. So within this green region here, I have 9 times 2, 18, x to the 5th dx. What is 18 x to the 5th dx? That's my du. So the next step, I'm going to change all of this to du. So erase all of this stuff, change it to du. Erase this stuff, make it u. So I have u to the 6th du. And there's an extra coefficient of a half in front, which doesn't bother me. Right, so that's what we mean by you might have to multiply by a constant times a derivative. Okay? Not a variable. You're not allowed to multiply a variable inside and outside, but any constant will work.
Mr. Holm.
All right. So
Mr.
let
Holm.
me finish this.
Yes.
Let me finish this quickly, please. Okay, so 1/2 u to the 6th. So 1/2 u to the 7th over 7 plus c. Okay, 1 over 2 times 7 is 1 over 14. Change u back to what it was. So u is 3x to the 6th minus 4 raised to the 7th plus c. So this is my final answer. Okay, and theoretically, if you take the derivative of this, you should get back the original. Okay, yes, somebody had a question?
Yes, my question is, how do you differentiate which is the u, for example, the 3x6 as opposed to being the 9x5?
Good question. Okay, so how do you know which is the u? I see this is x to the 6th, this is x to the 5th. Okay, the derivative of x to the 6th is going to have an x to the 5th. That usually tells me which way to go. Now, suppose I said, let this be the u. If this is x to the 5th, what's the derivative of something that has an x to the 5th? It's going to have an x to the 4th, which I don't see anywhere here, right? So normally for situations like this, you're looking for an exponent that's one higher than the other. So if you look at the pattern of all the previous problems, cube squared, right? So I know the derivative of a cube is going to be something squared, right? X to the 4th, x to the 3rd. The derivative of x to the 4th and some other stuff is going to be x cubed. That usually tells me the way to go. Okay. Way back in number 10, if I let this be u, what's the derivative of something that has an x cubed? That would be an x squared something, but I don't have that here, right? So you're usually looking for something with an exponent one higher than the other. So question over here, x to the 6th, x to the 5th. The derivative of something with x to the 6th is x to the 5th, correct? But if I take the derivative of something with x to the 5th, it's going to be x to the 4th, which I don't have. So that usually tells me which way to go for problems like this. Okay.
And the last one, and so where does the 1/2 come from? For example, dx times 2?
Okay, so 1/2. I cannot substitute unless I see 18x to the 5th dx. Okay. I can swap out the du for 18x to the 5th dx. The original problem did not have 18x to the 5th dx. It had 9x to the 5th dx. Okay. So I can't swap until I have the whole thing. It's almost like lock and key. Okay, I can't make that substitution until I see 18x to the 5th dx. I have 9x to the 5th dx. So I'll just multiply by 2. That's not fair unless I multiply by 1/2. So now I multiply the expression by 1, which is legitimate. I get an equivalent expression. Okay. Now I have 18x to the 5th dx. Here it is. 9 times 2, 18, x to the 5th dx, all within the green stuff. 18x to the 5th dx.
Okay, so for example, if that 9x5 would be 3x5, you would have had to multiply by 3.
If this had been a 3, and I need to bump it up to 18, then I have to multiply by 6.
By 6, yes.
Yeah, and I'll show you more problems that have that theme. But yeah, you're right.
All
They might
right.
not even have anything there. They might have just had x to the 5th. Then I have to put the full 18 over here. And then
Right.
1 over 18 outside. I'll show you more of those.
And you use the half to even it out?
Correct. So I multiplied the whole expression by 1/2 times 2, which is 1. Okay, you can't just arbitrarily multiply by 2 and get the same thing back. I can multiply by 1 in the form of 1/2 times 2. Okay. It's not a valid step to just multiply by 2. Okay. In some sense, it's almost like I can't go to the banker and say, take my balance and multiply by 2. They're not going to do that. Okay. They will multiply my balance by 1, which means don't do anything. You get something equivalent, right? Okay. So I multiply by 1 in this fashion.
All right, thanks.
All right.
I still don't understand
16.
why did you put 1/2 in the front? I understand that you put 2 at the back, at the end times 2, but the front is 1/2. Why 1/2?
1/2 times 2 is 1. Okay. Unfortunately, I'm at the stage where I have to cut off the questions in order to keep going. Okay. So I'll answer that quickly. You're allowed to multiply an expression by 1 and get the same thing back. You can't just multiply by 2. 7 is not equal to 14. Right? I can't go to the banker and say, take my balance and multiply by 2. They're not going to do that. That's not legitimate. They will multiply by 1. Okay, so I get the equivalent back by multiplying by 1/2 times 2. Okay, unfortunately, because of time, I will have to keep going. Okay, I do have a certain amount that I must keep up with. Okay, 16 looks like this. 3 times 5 minus x to the negative 3 dx. Okay, so I'll let u be 5 minus x. Okay. What's the derivative of 5 minus x? Negative 1. du is negative 1 dx. I cannot replace it until I see a negative 1 and a dx. I have to see that before I substitute. The original did not have a negative 1, and furthermore, there was a 3 in the front. That's okay, just bring the 3 outside. You're allowed to do that. So 3 comes out. I put in a negative 1 inside, which means multiply by negative 1 outside again. Okay, so the 3 that was there, just bring it outside. And what is negative 1 times negative 1? 1. So it's the same trick. I have a legitimate step. I'm multiplying the entire expression by 1. That means I'm getting an equivalent expression. Okay. But I need to put the negative 1 there so I can change this to du, the next step. I'm going to change that to u. So now in front, I have a negative 1 and a 3, so negative 3. This is u to the negative 3, and this is du. Okay, and now this is very easy by comparison. Okay, so leave the negative 3 alone. Power u to the negative 2 divided by negative 2 plus a constant. Add 1. Negative 3 divided by negative 2 is positive 3 over 2. Change u back to what it was. It was 5 minus x. So 5 minus x to the negative 2 plus c. And this time, the original problem started with a negative exponent. So I'm allowed to leave the answer as a negative exponent. Otherwise, I'd have to put that back into the denominator, right? So just put the 5 minus x squared into the denominator. But as it stands, you're allowed to leave it like so for this particular one. Okay, so again, if you have the derivative of u off by a constant, that's okay. Okay, you can adjust for it. So what was the derivative of 5 minus x? Negative 1. I didn't have a negative 1, so I put it there, but I have to put a negative 1 outside. So that means I've multiplied the entire expression by 1 in the form of negative 1 times negative 1. Okay. So what about the 3? Just put it out in front. Okay. Let's see. Yeah, I think I'm willing to go through the check for this. What's the derivative of this thing? Right? The derivative of a constant is 0, so no worries about that. Okay, -2 times that. -2 will cancel that 2. So the new coefficient is -3. Okay, so just think of -3. 5 minus x to the -3rd power. That works. Then by the chain root times the derivative of the inside. The derivative inside is -1. So I would have -1 times -3, which is a +3. So it worked. It definitely worked. Okay, 18. I know there's a lot of stuff there, but that's the reason why I use different colors. Ignore the red, ignore the green. Okay, the original was x cubed, 3x to the 4th plus 7 to the -4th power dx. Oh, I'm sorry, there's a 5 there also. 5x cubed. 5x cubed, 3x to the 4th plus 7 to the -4 dx. Okay, that's the 4th power. That's a 3rd power. The derivative of something with x to the 4th is x cubed. That tells me the way to go. Okay, so let u be 3x to the 4th plus 7. So the next step, instead of this mess to the -4, it would just be u to the -4. Okay, so let u be 3x to the 4th plus 7. What is the derivative of this? 12x cubed dx. Right, 12x cubed dx. I have 5x cubed dx. That's going to be okay. All right. Now, 5 doesn't even go to 12 evenly, right? So the best way to do it, just take the 5 outside. You can take the 5 outside. So 5 is going to come out. So pretend it's x cubed dx. You need a 12. Okay. So I put the 12 in. If I multiply by 12 inside, I have to put a 1/12 outside to balance it. So I've multiplied the expression by 1, which is legitimate. Okay, so one more time. The way I thought of it is look for a function and its derivative, or maybe a constant times a derivative. Okay. So the derivative of 3x to the 4th plus 7 is 12x cubed dx. The original had 5x cubed dx. That's going to be okay. Take the 5 outside. Okay, so pretend it's not inside anymore. Now I have x cubed dx. Got to have a 12 in order for me to substitute. So put the 12 inside, 1/12 outside. Now I can substitute 12 x cubed dx. So everything within this green region here, 12x cubed dx, I can change it to du. 3x to the 4th plus 7, I'm going to change to u. So it's u to the -4th du. What's in front? 1/12 times 5. 5/12. So I have what I want. All right, what's the integral of u to the -4? U to the -3 over -3. Okay, multiply that. So -5 over 36. Change u back to what it was. 3x to the 4th plus 7 to the -3rd plus c. And once again, the original problem started with a negative exponent. So I can leave my answer with a negative exponent also.
Professor,
Yes, question.
what is the constant in this case? Is it 5? You said.
I mean, this plus c? Or this?
You said, or the constant times the derivative.
Right, constant times the derivative.
Where is the constant?
In this case, well, to really get it down, it would be 12 over 5.
Uh-huh.
Okay. You say, what do you multiply 5 by to get 12? It's a fraction. So the easier way for me to think of it is take the 5 out and then multiply by 12 and 1/12. Okay. So formally, to answer your question, it'd be 12 over 5, which doesn't really help, in my opinion. So just do this process here.
You mean 5 over 12, not 12 over?
No, 12 over 5.
Oh,
To change it, to go from 5 to 12, you have to multiply by 12 fifths. Okay, see,
got it.
I sort of knew when I started saying that I would mess a lot of you up, but I'm trying to answer your question, which in my opinion doesn't really help.
Mhm.
So, okay, so if you didn't like what I just said, then forget it. But strictly speaking, what is the constant was what you asked for. The constant was 12 over 5. Okay, and to compensate, I put 5 over 12 here. Okay, so there we go.
I have a question, Professor. How
Yes.
did you get 5? Why did you get negative 5 over 36 and not
Negative
12?
5 over 36. You have the 5 over 12 here. This was u to the negative 3 over negative 3. 12 times negative 3 is negative 36.
Got it. Thanks.
Okay. All right.
Mr. Holm, I have a question.
Yes.
If the derivative of 3x4 is 12x3, why do we need to do the dx times 12 against the x3?
Sorry, can you say that again? A motorcycle just ran through my. Oh,
Yes,
sorry,
if the u equals 3x4 plus 7 is equal to 12x, the derivative of that, 12x3, why do we need to do the dx times 12 against the x3 and the 5?
Okay, so I cannot substitute until I see 12x cubed dx. Okay, the original problem did not show 12x cubed dx.
Okay.
U is equal to this.
So you're saying before the derivative, it already has to show that.
Before I substitute, it has to show 12x cubed dx. I can't change it to du unless I see 12x cubed dx. The original had 5x cubed dx. So that's why I put the 5 outside, put the 12 and 1/12, and then I'm good.
Okay, so although 3x4 does equal 12x to the third power, it needs to be in the problem.
I need 12x cubed dx. The derivative of this, I can't change that. The derivative of 3x to the 4th plus 7 is 12x cubed dx. Okay, and I can't change it to du until I see 12x cubed dx. That's why I need to put a 12 here and a 1/12 here, and took the 5 outside also.
All right, that helps out. Thank you.
All right. Okay, 20. What time is it? 6:25. I think we're okay. I'll let you have time for more questions as soon as I finish the formal lecture part. Okay, so 20, the original is like this. So ignore all the red stuff. 2x cubed minus x times x to the 4th minus x squared to the 6th power dx. Okay, I see the x to the 4th minus x squared. The derivative of x to the 4th is going to have an x cubed. I see that there. The derivative of x squared is going to have an x. I see that there. So that almost always tells you how you're going to substitute. So let u be x to the 4th minus x squared. Okay. So we're looking for a function and its derivative, or maybe off by a constant. Okay. So again, I look at this whole thing and I say, okay, there's x to the 4th. The derivative is going to be an x cubed. What's the derivative of x squared? It's going to be something with an x. That tells me let this be u. So u is x to the 4th minus x squared. Du is, what's the derivative of this? 4x cubed minus 2x dx. Okay. Now, how does that compare with what was the original? Well, let's see. I was given 2x cubed minus x. My du is 4x cubed minus 2x. So if you notice carefully, if you multiply that by 2, you get that, right? A little bit sneaky, right? If you take 2 times this thing, what's 2 times 2x cubed? 4x cubed. What's 2 times negative x? Negative 2x. So I can get the substitution that I want if I multiply the inside by 2, which means multiply outside by 1/2. Then I have what I want. Okay, because now this weird thing that I have in red is 2 times 2x cubed minus x. Again, don't worry about they're not together. Multiplication is commutative, meaning you can pick this up and put it over there. 2 times 2x cubed minus x is 4x cubed minus 2x. And there's the dx. So yes, I'm allowed to, as if it were, pick up my eraser, erase that, change it to du. Because I do have 4x cubed minus 2x. There it is, 2 times that is 4x cubed minus 2x. And there's a dx. And this is u. So I'm going to have u to the 6th power du, and there's a half out in front. So look at how much nicer the original problem becomes. It's 1/2 u to the 6th times all of this junk here turns out to be du. All right, so that's going to be 1/2 u to the 7th over 7 plus a constant. 1 over 2 times 7 is 1 over 14. So 1 over 14. Change u back. U was x to the 4th minus x squared. So change that to x to the 4th minus x squared to the 7th power plus a constant. And that's my final answer. Again, an exercise you might want to try for yourself is take the derivative of this, see if you don't get that back. You should, obviously. Okay, now we have some problems that are not quite like this. 26. So 26 actually does not fit the pattern. Okay. X squared minus 5 squared times 2x squared dx. I guess they threw this problem in sort of like saying, well, you can't always do the substitution. So try something else. You say, how do you know? Well, what's the derivative of x squared minus 5? 2x. I don't have 2x. I have 2x squared. Okay. And you say, can I multiply by 1 over x or something like that? No, you're not allowed to do that. Only for constants you can do that, but not for variables. Okay. Bottom line, the only way to do this problem, multiply this out. In other words, square this binomial, and then multiply it by 2x squared, and then that's it. Okay, so this does not fit the pattern of all the others that I've done. Okay, and I imagine there's some others that are like that. So I treat this as a minus b squared. Right, a minus b squared is a squared minus 2ab plus b squared, that shortcut formula. So I square this. What is x squared squared? X to the 4th. Minus 2ab. 2 times x squared is 2x squared. Times 5 is negative 10x squared. Plus b squared. So b squared is 25. Okay, so the square of x squared minus 5 is this. And now I multiply by 2x squared, and there we go. So I distribute 2x squared times that, times that, times that. That's what I'm indicating by the red stuff. Okay, so 2x squared times x to the 4th is 2x to the 6th. Then 2x squared times that, negative 20x to the 4th. And then 25 times 2x squared, 50x squared. Okay, so I finally got something that I can do, this polynomial here. All right, so 2x to the 7th over 7 minus 20 x to the 5th over 5 plus 50 x cubed over 3 plus a constant. Okay, and then 20 divided by 5 is 4. Leave that alone, leave that alone. Okay, so final answer is 2/7 x to the 7th minus 4x to the 5th plus 50 over 3x cubed plus a constant. Okay. Okay, then I'm going to do 30. I'll let you know 30 was the last one I was going to do. Okay, so after I finish 30, I'll show you a little bit of the next section, okay, as to where we're headed. Again, just to save time for planning ahead for the exam, so you can, ask your questions as necessary. So I'm not really going to do anything from 12.3, but I'll just show you where we're headed. It'll save me time on Thursday. Okay, then the rest of today, I'll let you ask questions. So, and even on Thursday, I'll do 12.3 and sneak in a little 13.2 on you. And then at the end, I'll give you the quiz on Thursday. So what's the quiz on? It's going to be on integration, just like stuff we've been doing. Okay. So as soon as I finish this last problem, I'll sneak in very little of the next section, and then I'll let you ask questions. And that'll be it for today. Okay, so for number 30, the original was cube root of x squared plus 2x times x plus 1 dx. Okay, and this should be a tip-off as to how to guess how to do the substitution. The derivative of x squared is going to have an x. There it is. The derivative of 2x is 2. Well, I have 1 here, but at least